First off, I'm going to invite Dr. Massimo. I always get your last name. Irisu. Okay. To come up and introduce his PhD student.
Thank you, Corey. Hi, everybody. I'm Massimo Iorizzo. I'm a faculty at NC State. I'm located at PHHI. I'm going to introduce Bryan Munoz, the first student to speak today. Bryan received his Bachelor in Agricultural Science at Hertie University in Costa Rica in 2000, and he's received his Master in Molecular Biology at University of Nebraska in 2008. He joined my lab in 2017, and he was part of a project that I started, was funded by Dole on banana, and then he's currently on his third year of PhD in the Horticultural Science Department. His project will focus on evaluating chemical composition of edible banana for crop improvement. So please, Bryan.
Let's see. Good afternoon, everybody. I know we're just coming from lunch, and it tends to be a very heavy sessions in the afternoon. But let's try to breathe and let's go easy on this and see how it goes. Let's see if I can keep you focused on my presentation, on what I came here to talk today about, which is banana. Now, I care about banana. Obviously, I work with banana. But the main question is, why should you care about bananas, and why bananas are so important for the world nutrition? So this is one of the first graphs that I want to present of why bananas are so important. And it is because bananas tend to be consumed worldwide. Everybody has at least tried once a banana. They are in our tables, they are in everybody's houses. Especially here in the United States is very important because in the United States, they are the second largest buyers of banana in the world, being the first Europe. And then we have China and Japan, and last, Latin America. Now, in our continent, America, banana is very important because we're the largest sellers of banana in the world. And notice that I'm making a distinction between seller and buyer and not consumer and producer, because those are different things. So we're the main sellers of banana. They are so important that they, for example, in Guatemala, they provide 20% of their capital or the money they make in the country a year. So it is a lot. But who are the biggest consumers? That is a different question. And the biggest consumers are Africa, the continent of Africa itself, and the subcontinent of India. Although the biggest consumer per capita of banana is Philippines. The biggest producer of banana in the world is India. And I'm gonna make some distinctions of why this is different between being a seller and a producer. And you will understand why. But first, we're gonna go with a little bit of the history of banana, where it originated. A lot of people don't know that banana came from East Asia and Asia Pacific. So we have the dotted line where it says Balbisiana. That is one of the main cores, Musa balbisiana, and the one that says Purmanica and Siamea down there, it is Musa acuminata. So we have the Musa A and the Musa B. Both of them cross to give rise to most of the bananas that we have today, which it doesn't mean that it's the only banana, but all the edible bananas come from those two. The other one are other species, and there are at least 70 different species of Musa around the world. Now, as I said before, those two genomes combine to give rise to banana, and this is where the story complicates, because we have two different species of banana. They are starting crossing to each other, and they gave rise to diploids, double A's, diploids, double B's. Then they start crossing, and then we have triploids, but now we have triples triple A, we have double A and B, we have an A and a double B, and if that wasn't enough, they cross again and they made tetraploids. So right now, we're talking that, and sorry, it didn't look so well, but we're talking that at least in the world, we are having at least 10,000 different accessions of banana, and I'm saying accessions, not varieties, and not cultivars, because of one important reason that I will expose next. But all those dots that you can see in the world map, it's where most of the banana variety are located in the world. There are at least 56 different centers in the world that conserve banana. So why accession and not variety or cultivar? And this is what it is very important, because the catalog of banana has just started to pick up interest. So there are different bananas in the world. A lot of people eat different bananas. Some of them can be repeated, some of them can be different. So one banana, I can call it one name in this country and another name in another country, but they can be the same banana, or backwards. We can have bananas with the same name in 3 different countries and be completely genetically different bananas. And this is just one example of that. This is plantains, French plantain, false horn plantain, and horn plantain. And as you can look at them, they look fairly different because of the bunch. But genetically speaking, they are very similar. So that is when it becomes complicated in the world of banana. And because banana has been a monoculture, a lot of mutation has been given rise. So we have mutations that can stand by themselves as different varieties. So the main variety that we have in the world is Cavendish. It's the banana that you know. It's the yellow one, the one that you have for breakfast, the one that you eat cookies and candies and everything. And that's what we think banana is. The piece of trivia that I always like to give in this talk is just to change how we think about bananas, is why the artificial flavor of banana doesn't taste anything like a fresh banana. And everybody knows that. It's just artificial banana never tastes the same. And you could say, well, artificial flavors, they don't come close to the natural thing, but not true. There are close flavors of artificial flavors that come very close, but not banana. And the answer, it is because it wasn't based on Cavendish, which is what we used to relate to banana. It came from Gros Michel, which was the variety that was cultivated before Cavendish. And as Dr. Jackson was putting it this morning, there is a danger with monocrops that already happened in the world with banana. Gros Michel was the leading variety that we had. And during the 70s, 60s, 70s, fungi called Fusarium race 1 came along, also known as the Panama disease, and completely devastated plantations over plantations over plantations, nearly destroyed banana as we know it. At least as an example, in my country, banana used to be grown in the southern part. After the disease came and wiped out all the bananas, they had to move the banana in the northern part because the fungi stays in the soil. So they had to find something that it was resistant to Fusarium, race 1, and they found Cavendish, and that's why we have and eat Cavendish. And besides, it is a very productive variety. But bananas can be chosen for an array of different reasons, can be chosen by colors. We have red bananas, and we have green bananas, and we have orange bananas, can be chosen by nutrition. And I'm showing as an example over there a variety that is called limeño, that some of these genes originated in Melanesia, and they are calculated that they can produce beta-carotene 270 times more than Cavendish can produce, which is fairly high. We can choose them by flavor. For example, in Brazil, they eat a different variety that is not Cavendish. It's called prata. And because prata is sour, it's more acidic than the Cavendish banana, and they don't like that. They like the sour banana. So it can be chosen by flavor. By texture, pisangawak, and texture is very important because banana is the main ingredient for baby food. Sweetness, of course, everybody likes sweet things. And the last one, but not least important, by resistance. For example, Fiat 25, it was developed to resist a disease called sigatoka or black spot disease, but on flavor, the banana didn't turn out to be very good. So another important part of the whole thing about bananas is that, as I said before, Cavendish is what we know because it is what it's more common down there. But this is the big distinguish. 50% of the banana produced in the world goes for export. That's why they are sellers and they are buyers. But it doesn't mean that all the banana that is produced in the world, it's for sale. Actually, 85% of the banana produced in the world are to be consumed locally. Now, from that 85% of the world banana that is produced, only 15% of that is Cavendish. That is the biggest main difference. 85% are local varieties or land races that they favor for different reasons. And this is important because only 60% of the banana that is consumed in the world is eaten fresh. Most of the banana are fried, cooked, baked. They go as an ingredient. You can make candies. You can make beer out of banana. You can make vinegar out of banana, wine. And that's why different communities chooses the banana that they seem fit for that reason. So, given all this panorama, we know that there is a vast biodiversity of banana out there, but we know very little about it. Genetically speaking, we're just starting to catalog it, and nutritionally speaking, we're not even starting to understand the difference of one variety of banana against another variety of banana. So that's exactly why I'm doing my research, to start to understand the nutritional profile of different bananas other than the commercial banana that we have, to have that as a base of genetic resources or a base for genes for breeding in the future. And in this research, at least, I'm focusing right now in 3 different metabolites. I'm focusing on sugar because sugar is an important component of flavor. And of course, it is the metabolite that gives us energy. So sugar is important. Phenolics or total phenolics, and phenolics are more often known as antioxidants, okay? And they are important for combating cancer, for example. And there are other phenolics, for example, dopamine, that it's the thing that makes us happy. So those things can be very important, and they would have, they can have pharmacological use or industrial use as well. And carotenoids, we all know the thing that make food looks yellow and orange. It is very important because it's also another antioxidant. The most popular one will be beta-carotene, that it's provitamin A. It's converted to vitamin A in the body. And it is very important for vision because it's part of the metabolism for the nerval system between the brain and the retina. So, starting of how I'm doing this research, I'm just choosing 27 different accessions or varieties of banana from different regions of the world. First, I'm going to characterize and compare those 3 metabolites that I just told you among themselves. Then I want to see how those metabolites grow or change as the banana mature. And 3, and this is a very important point, I want to see if the commercial post-harvest maturation treatment changed the nutritional profile of the banana. And this is a very important point. Most of the banana that we eat is not mature in the tree, because the banana needs to travel 2 weeks from Latin America to the United States, or 3 weeks from Latin America all the way to Europe. The banana needs to be collected green. When it gets green to the supermarket, they go into a chamber with a determined temperature and ethylene. And with that, they mature the banana. And that is what it's called commercial maturation. We want to know if that treatment, which is how we mostly eat bananas, affects somehow the nutritional profile versus if the potential of the banana just being mature in the tree, if the potential it's different when it's just on the tree. So these are some of the varieties that I will be studying. The 27 accessions were picked for different local market preference. They were chosen because people were telling me they have nice flavor, they look different, they are sweeter. So basically, this is more about what people think about those bananas or the potential that they could have to improve nutritional profile on commercial bananas. And those bananas, I took them from Costa Rica, from Dole's private collection. They have 250 different banana varieties or banana accessions in their collection. I just picked these 27, but eventually the whole collection will go through this process. Sorry. So, talking about how we started this, since we need to see how the nutritional profile changes throughout the banana maturing, we need to know what degrees we're going to be choosing. Commercial banana is cataloged in 7 different categories from 1 to 7, being 1 the green and being 7 the most mature when it has brown speckles. But that's a little bit too much, and that's only based on Cavendish, right? Because number 1, Cavendish, we know it. Number 2, Cavendish is yellow. In my case, where I'm working with red bananas, how can you see how much yellow there is in a red banana, right? So we decided to come up with a different way of doing this. So we came up with A, B, and C, being A when the banana is completely green, being B, what is called break of color, when you have 50% chance of, change from green to whatever color the banana will be, and you feel the texture starting to change. And C, when it's completely mature, texture is soft, color has changed completely. To do it, we decided to come up with this scheme. It's called from M1 to all the way to MC. The first 2 hands of the banana are left in the tree to mature. And the first thing that we need to do is to protect them, because trust me, birds, squirrels, every animal will eat them, even humans. By the way, it happened. From my own collection, from my own plants that I was collecting, I had to repeat it twice because people came to steal my bananas, the ones that I left in the tree. And then from 3 to 5, they were taken to this, they were cut down, randomized, and they would put to the maturation chamber. So the idea is to leave plants on the tree to fully mature and take plants from the tree to fully maturing chambers. And this is pretty much how it looks like. We got the 27 accessions. From every accession, we decided to pick 3 different plants. From every plant, we left some to mature in the tree. We took some for the chamber maturation. For the chamber maturation, we examined 3 different maturation levels, A, B, and C. From the natural maturation, we evaluated only A and C, because it's harder to pick when they are B on the tree. I mean, some of these trees, we're talking, they are 12 feet tall, and it's not really easy to see. You have to go with something to look them up. So for a total of 324 different samples, I also collected not only pulp, but I also collected peel, because peel would be very important for total phenolics. All the samples were brought to the lab. In the lab, they were flash frozen with liquid nitrogen. Then they were lyophilized, converted into powder. All this process was done under yellow light to avoid affecting any of the nutrients. And they are sealed in black tubes, kept at -80 until we're able to process them. So the first thing that I'm going to talk about, it was the sugar and how sugar was done. So we took that lyophilized powder, we did extraction with ethanol, and we did HPLC to examine 3 sugars, glucose, fructose, and sucrose. being sucrose, one of the important traits because it's what it gives sweetness to the fruit. Mannitol, which is an alcohol sugar, was used an internal standard, and we also use this data to do something that is called NRI spectroscopy, which is a non-destructive way of measuring different nutrients. So this is the first results that I'm getting, and I want you to focus your attention on the screen. What it's going to be always in red is Cavendish, which is the banana that we eat. And what I marked with green arrows are the ones that are strikingly different or that they have higher. So the first statistics shows that, in fact, yes, within varieties, there is a lot of valid variation. The same, there is variation between maturation stages. We have green, A, B, C, mature, and then natural mature C. And one of the first things that you can start noticing here is that C, mature in the plant, seems to be a little bit higher in sugars than C when it's mature in the chamber. Also important to notice that one of the most interesting varieties that we found for sugar was Brie. And the interesting part about Brie is that this variety was just collected from a Brie region, which is a native region in Costa Rica. So it's not even commercial, it's not even a commercial variety. It was just picked in that region. And up to this day, there is little genetics known about this variety. When we go to total sugars across different maturation stages in the pulp, we can see two things here. Number one, when we go from A to C, of course, we see a tendency to grow. And that's natural. We have banana that is dissolved starches, making more sugar. But what is important here is that it doesn't matter, and it's independent of variety, no matter what variety you are going to pick, will always be the same. It will go, it will be different. So there is not a dependency on variety, and we could say with certainty that A, B, and C are different and distinctive maturation stages, at least for sugar. And when it comes comparing natural maturation versus chamber maturation in fully mature fruit, we can see that natural maturation is also way higher than chamber maturation, and also is statistically significant. And we can say that no matter what variety you will pick, it will always have more sugar when it's left in the tree. This is some of the correlations. What I want you to get out of this graph, and what I think it is the most important, is that glucose and sucrose, which are the sugars that are in less amounts in the plant, they keep a correlation, meaning the plants that have lower glucose and fructose, when banana is green, will have lower fructose and sucrose when they are in the higher maturation stages. But the one that keeps on swinging a lot is sucrose. Sucrose do not keep the same correlation as glucose and sucrose has, meaning that sucrose would be the sugar that will be changing the most across varieties, across maturation stages. And this is just to show you what the NIR is. It's called near infrared spectroscopy. And what it does is that you take a sample of anything and you blast it with light. And then there is a detector that will pick the near infrared wavelengths, and they will try to correlate that with any data that you're going to give it. In this case, we gave it sugar, and they would see if there is any correlation. If you find a good correlation, you can keep just using light to measure any sample that you want, meaning that you can reuse the sample again and again and again for different nutrients. And in our case, at least for total sugars, we found that there is a 96.5 R-square or correlation between what it is predicted by NRI and what it is with HPLC, meaning that we have a pretty good correlation, and we could use NIR to start measuring sugars in banana. So talking about total phenolics and what I said before, total phenolics are antioxidants. We did pulp and peel because it is known that peel in banana will have higher phenolics than pulp would have. So we did an acidized methanol extraction, and then we did the FC method, which is a redox reaction that changes the solution color, and then we look at the absorbance of light with that change of color, and that will give us an approximation of how much total phenolics in total there will be in those samples. So again, the same graph, A, B, C, and natural maturation C. What you see in red is that what we eat, Cavendish, and then we can see the other ones. So first thing first, with total phenolics, we can see that they start high when they are green. They keep on reaching highness when they are in B, and they start going low when they go in C. What we can see also is that they go even lower when they are left in the tree. But now, this tendency does not happen to all of the banana. Some banana reach their peak on A, some banana reach their peak on B. So there is a tendency of, we'll have to look every single accession, every single variety by itself. We cannot make a generalization like we did with sugar, that if we pick any variety at any given time, we will know more or less how much sugar can we expect. With total phenolics is completely dependent on variety. But what we could say is that total phenolics reaches a peak in between A and B. And this is how it looks for peel. The story goes exactly the same, with the difference that in this case for peel, B will be the highest, independent of variety. Also, something else that you can see the difference between pulp and peel. As you can see, well, first peel will have more, as expected, but also the lines are a little more uniform, while in pulp, the lines are jumping all over the place, meaning there is a little less variation in peel, in total phenolics, than there is in pulp. And we can see this a little bit better over here when we compare peel and pulp at different maturation stages. We could see how peel keeps uniform across different stages, but we see that in pulp it changes across different stages, as I said before, starting some change between A and B and going down to C. But when we go to the chamber maturation, we could see a very striking difference. When we're talking about peel and pulp, we could see that the total phenolics in both low, very, very low, go low, very low, especially in peel. So now we know that banana left on a tree, mature in the tree, the total phenolics will go down if they are left both in peel and pulp, and especially in peel. Difference, what we found in sugar and what we found in total phenolics about correlation. The correlation of total phenolics goes very well for stages A, B, C. Okay, for peel and pulp, you can kind of follow the lowest accessions will have low in A, the highest accessions will have high in A, as high in C, low in A, low in C. And that goes true until we hit natural maturations, where the correlation changes completely, but in peel it's kept. Or at least peel has a higher correlation in total phenolics across maturation stages than pulp does. So to finish with this talk, I can give you a lot of technical conclusions that we could have about this. The important thing to take home is, number one, nutrients changes across different maturation stages. And it is important because, as I mentioned before, banana is not only eaten fresh or mature. Number two, we know that the maturation in chamber changes the nutritional profile. It doesn't mean that we had to eat banana picked from the tree or banana mature on a chamber. It's just the way it is, and now we know that that treatment does has an effect. And let me tell you why this is important, especially for breeding purposes. Because when you're breeding banana, you need to understand what is their potential in nature to give sugar, or their potential to reach high total phenolics. But what potential are we talking? The banana, are we eating it fresh? So we want the banana that has the most sugar when they are maturing in chamber, or we want the bananas that are left alone in nature and they reach their highest sugar potential? And this is a very important question that we need to answer in terms when we start digging for different mutation or genes for breeding purposes. And with that, I just want to give thank you for a lot of wonderful people that has helped me through this. Adult people, the PHHI, the P2EP, even NC State in Campus Rally, they helped me to develop the statistical models to analyze this data, and to all of them, thank you very much. And now I'm open for questions.
Phenolics regulation level in between the peels and the pulp?
We just know that there are different tissues. Little is known. I mean, when you go first, this is the first kind of this study that it's been conducted in so many accessions with different maturation levels, and really nobody has even looked at plants that are bananas that are still attached to the tree, because seriously, commercially it doesn't make any sense. Bananas are usually cut when they are green and they are taken to the market because they need to survive. If you leave bananas in the tree, usually animals will eat it. So you are left with no banana, and that's why it doesn't make sense to do this kind of things. But now we know it does make sense because we're looking into it, and now we know it changes, and now we know it's not only different, but it changes depending of the variety that you pick, depending of how you do it, depending of when you pick it. So yeah, little is known about this regulation. We're trying, or we will look forward to a real profile of total phenolics, and see if we can start looking at different pathways in metabolism of phenolics. We have one more question here, and then we have one more there.
So when thinking about the differences in total phenolics between the fruit that was stored, like collected green and then stored for commercial shipping, and then fruit that was allowed to ripen on the tree, what do you think it is, like what part of that process do you think it is that's causing that difference in total phenolics? Like, could the storage be in dark and so light isn't breaking it down?
What it comes to mind is that, yeah, total phenolics are, a group of antioxidants. So one of the things that we know is that if you are going to pick a fruit, leave it in a non-stressful environment, usually the fruit will remain well. When the fruit is exposed to the environment for longer, there is going to be an array of different environmental stresses and probably some biotic stresses too, as well, that may change the profile of phenolics in the fruit. We have one here, one there, and one there.
So I have more of a technical question. I'm new to this field. I'm an immunologist, so bear with me. So the graph that you showed in there about sugar content, you did it at per 100 grams of dry weight. So if I'm eating a banana, right, how much is the equivalent between 100 grams dry weight versus
Okay,
fresh?
that's a very important question. In our study, we're calculated that it's around 30 to 35% dry weight to fresh weight. So what we use is, let's say, is the 35% of the banana. And depending on the banana, because this is another thing to answer, we have the babies that are around 50 grams, and then we have one that is called the true horn, the tin dog. Ooh, actually, no, Uamoa, which is a big one that looks like a squash. That one weighs almost a kilo, 1,000 grams. So we're talking also a different race of how much a fresh banana would weigh. We have one question over there. Okay.
So this is kind of piggybacking off of the environmental stresses that can be on the bananas. You've been studying the bananas now for years. Have you noticed any changes in the environmental stresses in terms of weather fluctuations that are kind of extreme? And if so, have you noticed any significant change in the quality or total phenolics?
Actually, we're trying, through the statistical model, we're trying to look a little more into that and how that variation is coming across from true changes between different repeats and how much it is just variety and how much it is maturation stage at this moment. We're still processing that data and trying to get those numbers out. One thing that I could say is that this collection is in a tropical environment, and tropical environments usually have the same amount of light throughout the year. What changes the most would be the amount of precipitation, meaning it will rain 3 days a week instead of 7 days a week. But yeah, those would be more or less the environmental differences in terms of temperature, in terms of relative humidity, in terms of amount of light. They are pretty uniform across the year. What changes the most is the amount of precipitation.
Hey, Brian, I'm going to make a pass to make a goal. So easy one. So among the banana that you found, is there any one of them that has high phenolics in the pulp that will be for potential use for breeding or for consumption?
Yes, I mentioned that for sugar, but you're absolutely right. I did not mention it for total phenolics. But as you can see, the green arrows over there, I think the most interesting ones are Pisang Jariwaya and Pisang Lidi. And I'm actually very interested in Pisang Lidi because even though Pisang Jariwaya has some of the highest total phenolic content, as you can see, Pisang Lidi keeps uniform through A, B, and C, which I think it is quite interesting. It goes a little up and a little bit down, but it doesn't go too much up or too much down. So it doesn't matter about the absolute amount. But I think between Pisang Jariwaya, Pisang Lidi, Pisang Lili, Tabmayo, it's kind of interesting on stage A, but it goes lower on stage B, and that's what I was saying before. And as you can see with Cavendish, I mean, with certainty, no matter how much this fluctuates up and down, there is no doubt over there that there is a lot more varieties of banana that has higher total phenolics content in the pulp than the Cavendish that we eat. And that is one take-home message, because the same applies for sugars. There's for sure varieties out there that can be sweeter than the ones that we eat now. Not too strong, but they actually, yeah, not too strong. According, the more sugars you have, the lower phenolics it goes, but the correlation goes around 0.40. But yeah, I mean, there is a tendency as the sugar grows, the phenolics goes down. 27. Yeah, I mean, this will hopefully, and I wish we could have more high-through methods, because this should be done in 250 different varieties. I mean, to have a better understanding, a better profile of bananas, because as you said, you know, I believe the future is in biodiversity, the genes that we need in the pool of things that we eat are out there. We just still don't have them.
This will be our. Sorry, you got. I was gonna say this will be our last question for Bryan.
Okay.
If we will have a break after the
Yeah.
next speaker, and hopefully you'll have a chance to talk to the presenters individually if you have additional questions that we don't get to.
So with the end goal of finding the perfect kind of balance between the sugars, phenols, and carotenoids in those banana accessions, have you gotten any more insight into how this research is applicable in retail and getting those different kind of accessions out?
Certainly there are different things that will apply to this. If you ask me, my personal opinion, I mean, there are varieties out there already that will be high in this or high in that we certainly can use. Banana breeding is very hard. Not impossible, it's very, very hard. We have the transgenic technology, but the industry in banana completely understand. They don't want to mess around with it a lot because of public opinion of what transgenic, or in this case, in banana, from banana to banana will be cisgenics. But there is a little bit of resistance of going that way. There are some of these varieties that are already very good as they are. And I think for the purpose or for whatever purpose you need them, whether you need them for beta carotenes, we have a banana for that. You want a sports banana with high sugar content to give you that boost, we have a banana for that. We need a banana to help with cancer. We have already a banana for that. And that's how I think it should go. A little bit of more diversification rather than just picking one commercial variety. And I know it's kind of hard because that's the way it works. But at least we'll have this genetic pool that we could use to improve on those varieties. Thank you very much.